Okay, so statistics. So what's the agenda? We're going to go through essentially all the chapters 1 through 9. And the format of the exam, if you guys know, 50 multiple choice and 50 problems. And so with that in mind, I'll make sure to hopefully highlight some of the things which I think are good multiple choice, and then some of the things which you should expect to have problems about, to kind of give you a little more, a better approach. So let's start out. Chapter 1, Introduction. So you're going to see some multiple choice, some big things. What is statistics? You know, it's a way of getting information from data. Let me sharpen this so that you can see. It's a pattern language, just a buzzword. Science, it's all about, the whole course is all about getting information about a population, the world, everyone in Canada, everyone on the internet. But in statistics, the way you do that is you have to take a sample. You have to take 100 people, 1,000 people. You have to take a small subset, use statistical analysis to make inferences about the big population. Because in the real life, you can't interview every single person in the world on if they have eaten today or not. You only can take a sample. That is what we're doing managerially. You're going to do that in your own business. So you'll take case studies of 2 of your stores, and you'll get that data and then blow the result out, let's say a marketing campaign, out by 100 of your stores. That's what we're doing. That is statistics. Population versus sample, know the difference. Population big, the sample a bit of it. And it looks, so essentially you've got the big population, and a couple of those points make up the sample. And so the difference between those 2 words is there's a parameter and a statistic. And essentially one's for population. A parameter describes a population. So the mean age in Canada is whatever, 54. That would be a parameter. But a statistic would be the mean age of this room is 19 quarter. That would be a statistic. Again, buzz, multiple choice, they could ask a little paragraph and say, this is a what? This is a parameter statistic, and you could just get confused by all the different terms. Just know the difference. Descriptive versus inferential. Descriptive is, it's all about arranging, summarizing the presentation of data on a group to reach conclusions about that same group. So I'll take you guys and I'll say, well, the mean age is 19 and a half, and so that means with you guys, I'm going to say you're blah, you're able to drink. Sure. Whereas inferential statistics is when I use this sample data and I say, you guys, the average of this 10 students is 19 and a half. Well, that means I'm going to say the average of all the York students are 19 and a half, give or take, because I took your result from this small sample. That is the difference. Again, buzzwords, multiple choice. You know, here's an example, what type of statistic is this? That's all you're looking at here. Again, here's some good multiple choice. Data sources and study types. So there's 2 types of data. You either can do it yourself, which is a primary source, or you get it from someone else, which is a secondary source. So if you're using stats from a research paper or Statistics Canada, it's a secondary source. Again, what could they ask? They could say, well, you went to Sobeys and interviewed all these people. This is an example of a primary data source or a secondary data source, right? Where they'll put a tertiary and they'll put like something random. And so, again, an example. And then there's 2 study types. You can observe, which has no controls, no hypothesis. You just observe people coming in and out. Or you do it experimentally, which is where you actually have hypotheses. You say, I think the students in York are all 19 years old. That's what I'm thinking, and I'll try to test if that's true or not. The first one is just, how old is everyone here at the university? And then you'll just go from there. So again, 2 different types. I'm going quickly through this just because this is the earlier stuff. Please stop me if anything is, you know, I'll need to see, you know, just anything, hands, kick, cough, hiccup, whatever, just get my attention. And so, again, going with the types of data, there's 2 different ways, and it's an interesting chart. It's not really that interesting, but when it comes to the timing of taking that data, you can do it all at once, or you can do it over a series of days or months or years. So it's cross-sectional if I'm doing it right now, or time series if I'm doing it month by month. I want to look at the sales from month to month at my stores. Data type, both of these can be either quantitative, numbers, or qualitative, you know, any type of qualitative properties, color, shape, whatever. And then you've got the data types, so the actual levels of data, everything from nominal all the way to ratio numbers. So nominal being apples versus oranges versus bananas, all you can do is count them. Nominal, you can't do much with more than that. And then you have ordinal, where you take it up a notch, in which there's some sort of reason why 1 is lower than 5, because you want to ask people, how well did you enjoy this exam aid session on a scale of 1 to 5? Well, because you can do more statistical data types, you can get more information from that, because you can take like the mean and the average and whatnot. But it's not interval or ratio. Interval and ratio just are when you have decimal places and those numbers mean something significant. It's time, it's money, it's something which you can use all the different types of arithmetic and all the different stats that we are going to discover right now with those types of data. And so it's least amount of information or lowest to the highest amount data types. And so I think I did this cross-sectional, it's just information for you to see. Quantitative versus qualitative. Yes, I just talked about that. Here's the table again. 4 different types. As I said, nominal. Apples, oranges, pears. You can only do a bar graph or a pie graph. You can only do the proportion of people who liked apples versus oranges. Ordinal, as if it's ordered rankings. So you can take the average is the next stage. You can take the mean number. You can do some of those low-level ones. And then take it up a notch to interval. Well, this is where you have real numbers, so temperature or time or money or whatever. Real numbers, you can do all statistical methods. But there's no natural or fixed 0 point. And then the last one is ratio data. So this is the real one where most of our statistics falls within that. It's where you actually have a natural fixed 0, which means 0 means 0. In temperature, 0 is not an absolute, it's not fixed, because 0 in Celsius is something in 32 in Fahrenheit. So when it comes to having a fixed 0, what is 0 temperature? Well, there isn't. And so that's the difference between interval and ratio. So almost every single one of your questions are really in ratio data, because there's a 0 which means 0 height, 0 which means 0 time, 0 which means 0 weight, you have no weight, whereas temperature is the greatest example for interval, where 0 is, there's no 0 temperature. Know the difference, because that's a quick and easy multiple choice, where they say, here's the type of data, what is this? And the classic is people will pick interval over ratio data, right? Because interval is, you learned interval when you were in grade 2, grade 4 maybe. And so that is like where you always jump to, but it's a more distinction in statistical terms, it's called ratio data. Any questions, concerns? You guys love this, right? This is so good, easy. Now it's for easiness, right? Cool. 2 and 3, tabular and graphical techniques. So actually, if you want to stop